So let's go through this question on statistics. The table below shows the height of med3 sample. So you can see the sample and then want to calculate the mean of the sample heights, the mean of mean samples, and the mode, the median, the variance, and the standard deviation. Right? So first thing is let's determine the mean of the sample heights. So you can see we have got 10 samples, S1 up to S10. But then how do we determine mean of a sample? So when you are determining mean, what you simply do is the mean, because these are samples, right? This is not a true population. So the population of these medical students would be more than what we have here, but we just picked some of those people. So because it's a sample, when you are finding the mean of a sample, so samples, you need to know that we use English letters. For mean, we are going to use that. If it was a population, becomes different. The mean, we use mu. Okay, so that's for the mean. That is the same going to be with the variance or the standard deviation. Let me put that standard deviation. So standard deviation, we are going to use S for a sample, that's English letter. For the population, we are going to use sigma, right? Because population is the actual things that you are dealing with, the actual number of people. So let's start with the mean population. How do you, the mean of the sample, sorry, that's question A. So how do you do that? So the mean is actually given by you adding all the terms in your sample from the first term to the last term, all the terms in your sample, and then you divide by how many the numbers you have. So that is what we want to do here. Starting with S1, we are simply adding 1.56 plus 1.60 plus 1.7 plus 1.65 plus this plus this plus this. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when you get to sum this and then divide by 10, what you are going to be able to find is going to be 1.6. So that is going to be the mean of the sample. And then we also add S2 of them and then divide by 10. It will as well give us 1.6. This S3 will also give us 1.8. The next will give us 1.7. The other one will give us 1.7. The other one will give us also 1.7. The other one will also give us 1.7. The other one will give us also 1.7. This one will give us 1.6. The last one will give us 1.7. So that is how we'll be able to determine the means of the sample heights. Now I want to find the mean of the mean samples. Can you see that we have got the samples? We have determined the mean of the samples. Now I want to get the mean of the samples. So when you are getting the mean of the samples, that is going to be given by mu, and then we'll put mean there. So remember, both this is representing the mean of the population, right? Mu. This is the mean of the sample, but we are finding the mean of the means. So that is how we write it. Because these are the means, but we are finding the mean of those means. Right, so we hope we get that. And that is basically given by the sum of all the means, right? In this case, it's all the means. And then we'll divide that by how many they are, divided by n. And so we have got 1.6 plus 1.6 plus 1.8 plus 1.7. We can simply write that 1.6 plus 1.6 plus 1.8, and then the next is 1.7 plus 1.7. They were like 4. 1.7 plus 1.7, and then plus, let me count them again, 1, 2, 3, 4, and then we have got another 1.7, the fifth one, and then another 1.7, and then we have got 1.6. Okay, hope that, how many are they supposed to be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 of them. 1 2 3 4 5 6 7 8 9 10. All right, so they are balanced, and then we'll divide by how many they are. So these guys are 10. So when we get to add on top and then divide by 10, we are going to be able to get 1.68. So this is a mean of the means, which we can as well round off, and that will be 1.7, right? So that is it. The next question is asking us to find the mode. What is the definition of the mode? Mode is the number of highest frequency. So which number can you see is having the highest frequency? You can see if you just look at the means, 1.7 is a lot of it. So 1.7 has got the highest frequency. It's appearing more times. Therefore, the mode is going to be 1.7. How about the median of the heights? So how do you determine the median? Median is basically the middle number. We're going to get the means, okay, because these values are a lot. Imagine you wanted to get off this and then pair them up in ascending order. It will take you forever, isn't it? So simply get the means, arrange them in order, and then be able to determine which one is on the middle. So if we get these means, I can simply use here. The smallest we have is 1.6. We have got another 1.6. You can see there's also another 1.6, and then we have got 1.7, 1 2 3 4 5 6. So there are 6 of them. 1.7, 1.7, 1.7, that's the 3. 1.7, that's 4. 1.7, that's 5. 1.7, that's 6. And then we have got 1.8. Remember, we're finding the median, the middle number. So what we'll be doing is we'll be cancelling. I'll cancel this one, I'll cancel this one, 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 cancel this one. Can you see that we have remained with two numbers on the middle? So if there was another number on the middle here, we would have cancelled this, and then we would have just gotten that number that we would have found. But since there are two numbers, to find the median, median then is going to be, you get these two numbers, you add them, and then divide by 2. So it will simply give you 1.7. That is going to be the median, the middle number. Okay. And then the next question, we want to determine the variance. So how do you find the variance? This, when you have got a population and when you have got a sample. Remember, for a population we use Greek letters, and here the standard deviation is given by, the variance first. Variance is sigma squared. That is going to be given by the sum of each number minus the mean, and then you square it, then you divide by how many they are. But for standard deviation of a sample S, it's given also by the sum of each term, but then you are removing mean, and mean here we use the English letter, right? You square that, but you divide not by n but by n minus 1 for a sample. Please take note of this, right? So what are we dealing with? Are we dealing with a sample, or we are dealing with the population? We are dealing with a sample, so we'll use this formula here. So what are we going to do? First, we are supposed to find the x minus the mean. Now in this case we'll not get, because x is representing each one of these terms, and then we remove the mean. Each one of these terms remove the mean, but that will take long, right? So we'll simply go to this guy. We'll be getting the mean, and then from the mean we are going to remove the mean of the means, right? So from the mean we remove the mean of the means. Okay, so already you saw the mean of the means. That guy, we get, what symbol did we give it? You can see the symbol that we give it, so it's acting more like a population. So therefore, to find the standard deviation, we are going to say Standard deviation, we are taking it as a population because we're using the mean or the means. And that, we are starting with variance. Variance squared is going to be the summation of the mean, each mean we are removing, the mean of the means, and then we square the answer, and then we are going to be able to divide now by n. So what we can be doing is simply subtracting. Remember, the mean of the means is what? 1.7. So we'll start with this one. So what we are trying to find is mean minus mean of the means. So 1.6 minus 1.7. But remember that term we are also squaring it, right? So 1.6 minus 1.7, that's negative 1 squared, that's 1. 1.6 minus 1, oh sorry, 1.6 minus 1.7, that's negative 0.1. Negative 0.1 squared is 0.01. Same here, it will be 0.01. 1.8 minus 1.7 is 0.1. You square that, that will be also 0.01. 1.7 minus 1.7 is 0. 0 squared is 0, so this will be 0, 0, 0, 0, 0. Even the last one here is going to be 0. For this one is going to be 0.01. So we'll simply add these terms. 1, 0.01, 0.01, 0.01, 0.01. How many are they? There are the 4 of them. Remember, it is the sum of the mean minus mu squared. So we have got 0.01, another 0.01, another 0.01, another 0.01. How many? 1, 2, 3, 4. And then we have got zeros, negligible, right? And then divided by how many are they all together? The terms were 10. Okay, like that. And that is going to give us 0. Okay, let me just do that. On top, if you add 0.01 or just multiply 0.01 by 4, that will be 0.04. Then you are dividing that by 10. That is going to give us, so it was 0.04 over 10. Dividing by 10 just means the decimal point to move one step behind. That will be 0.004. That's the variance. Now the standard deviation, which is basically, standard deviation is the square root of the variance. So simply get a variance, you square root it. So square root of the variance, and that is giving us 0.063. So that's the meaning. That's the variance. That's the standard deviation. What does standard deviation even mean anyway? So standard deviation just tells you how close numbers are, the proximity of numbers. So if you find that a standard deviation is a very small number, it means that the numbers are very close to each other. Can you see 1.6, 1.6, 1.8, 1.7, 1.7, 1.7? The numbers are so close to each other. That is why their standard deviation is that small. Otherwise, if the numbers were much spaced away from each other, it would not be a small number. Another thing that we should just get to know is that, let's say if you have got numbers, because these, the mean, the mode, the median, the variance, these are known as measures of the measures of dispersion and the measures of central tendency. So mean, median, and mode, these are measures of central tendency. You are just trying to see what number is on the middle. So let's say you have got 1, you have got 2, 3, 4, and 5. If you find the mean of these ones, let's try to find all of these so that you just see the meaning of these terms. So the mean is going to be 1 plus 2 plus 3 plus 4 plus 5. And how many terms do you have? We have got 5. So if you add them and divide by 5, you are going to find 3. And then the median, what is the median? Median is the number that is on the middle, that is a 3. How about the mode? Mode is the number with the highest frequency, so for this one there is no mode because they're all appearing the same, right? Now let's say if you had 1, 5, and 1000. Let's find the mean. So the mean for this one, simply add 1 plus 5 plus 1000. Divide by the other three of them, so that will give us a 335.3. Can we find the median? The median is going to be what? Median, the number on the middle of these three is a 5. Now looking at the mean and the median, for numbers that are dispersed, which one do you think is telling you the number that is on the middle? Which one is communicating really the best to do with the central tendency? Between 5 and 335, which one do you think is the number that is between 1, 5 and 1000? Which one is the number in between? Of course, 335 is communicating more. What does this tell you? This tells you that for numbers that are more orderly, not too much dispersed, the best that you can use to communicate central tendency is going to be the median. But for numbers that are dispersed very much from each other, the median might not give you the best view of the central tendency, but the mean is going to give you, because 335 is more on the middle of these three numbers than 5 is, because 5 is too much away from 1000. Hope we get that. Thank you so much for watching, and here we end.